Welcome back. Today I'm going to be talking about tessellations. You might not have heard of tessellations before, but I can definitely guarantee that you've seen a tessellation once in your life, at least once, but probably very often. One way we can fill the blank plane is to use the same shape over and over without overlap. For example, on this first image on the left that we have, you see that we have the same arrow kind of shape repeated over and over, but in different colors. And you can see that it fills the entire space without any gaps. Same for these images over here. On this image at the top right, we used a square. And for this image at the bottom right, we used a weird kind of rock shape, but it's the same shape over and over, and it fits perfectly together, filling the entire space. Now I'm going to tell you about what kind of shapes we can use to fill a plane. Here I have an assortment of shapes, but only a few of these shapes are what we call regular polygons. Which ones are the regular polygons? Well, to figure that out, we first have to know what regular polygons are. Regular polygons are shapes with all sides of equal length and all angles of equal size, like a square or an equilateral triangle, like we talked about in our previous class about geodesic domes. So, going back to the shapes that we just looked at, which ones are regular polygons? This one is a regular polygon because it has all sides of equal length, all angles equal size. So this one's called an equilateral triangle. This one is called an octagon, which has 8 sides of equal length. This one's a hexagon, which has 6 sides of equal length. This one's called a pentagon, which has 5 sides of equal length, and this one's a square, which we know has 4 sides of equal length. So in the beginning, we had 8 shapes, but only 5 of them were regular polygons. Okay, so now that we've tried that, let's start talking about how we can fill a plane using regular polygons, because you probably found out that we can't just use any combination and always end up with filling the plane without any overlaps and without leaving any gaps, right? Okay, so I just tried filling a plane with the equilateral triangle. That's how it worked out. Now let's try the square. Okay, that works out. That doesn't work either. And in this leftover space, if we try adding an extra hexagon, we realize that we end up with overlap, which we've been trying to avoid. So that doesn't work out. How about the octagon? Oh no, same thing for the octagon. So for the equilateral triangle, square, and hexagon, we're able to fill the entire plane just by repeating those shapes. But for the pentagon and octagon, we need to use a different strategy. First, what's so special about the triangle, square, and hexagon that allows it to fill the plane by repeating its shape? Based on the vertex where the regular polygons are gathered, that's represented by these big black dots in the center, the shapes are packed tightly and they don't overlap. Before we talk about the pentagon and octagon, we're going to start by defining the tessellation. The tessellation completely covers a plane or space without overlapping or leaving any gaps. So basically what we've been trying to do this whole time. Ancient Romans decorated the walls or floors of their buildings with square-shaped stones or tiles called tessella, and that's where the word tessellation comes from. We have 2 types of tessellations, and those are the regular tessellation and the semi-regular tessellation. The regular tessellation is a tessellation made from only one kind of regular polygon. So this is a regular tessellation using equilateral triangles. This one's a regular tessellation made using squares. And finally, this one's a regular tessellation made using hexagons. What about semi-regular tessellations? Semi-regular tessellations are tessellations composed of 2 or more regular polygons, where the number and arrangement of polygons meeting at a vertex are the same. So we're no longer repeating only one shape, but now we're repeating 2 or more regular polygon shapes. And these are the 8 examples of semi-regular tessellations. This one over here you can see uses a hexagon and equilateral triangles. Now, why don't we dive into the math involved in polygon tessellations? How about tessellations made with regular polygons other than equilateral triangles, squares, or hexagons? Namely the ones using pentagons and octagons, which we discovered had problems earlier. With the equilateral triangle, square, and hexagon, we can make regular tessellations using these shapes because they can create 360 degrees. We have one angle of an equilateral triangle is 60 degrees. If we have 6 of those, we get 60 degrees times 6 equals 360 degrees, and that's one whole cycle. Same with the squares, one angle of a square is 90 degrees. If we have 4 squares, we have 90 degrees times 4 equals 360 degrees. Finally, with hexagons, one angle is 120 degrees. If we have 3 hexagons, we have 120 degrees times 3 hexagon equals 360 degrees. However, the problem with pentagons and octagons is that they cannot make 360 degrees just by repeating pentagons or octagons. For pentagons, we have leftover space, as you noticed earlier, because one angle of a pentagon is 108 degrees. If we have 3 pentagons, we have 108 degrees times 3 equals 324 degrees, which is less than 360 degrees. And that's because we have 36 degrees remaining. How about if we have 4 pentagons? Then we have overlap, because then we end up with 432 degrees. That's way larger than 360 degrees, and that ends up with overlap, which we're trying to avoid. So, doesn't work out. The equilateral triangle, square, and hexagon can make regular tessellations because their interior angles are divisors of 360 degrees, meaning they divide 360 evenly. However, the problem with the pentagon and octagon is that their interior angles are not even divisors of 360. Now let's talk about transformation tessellations, which are tessellations formed from transforming regular polygons. How do we transform regular polygons? Step 1. We cut a portion of the regular polygon and paste it onto the opposite side. So let's say this is our shape over here. We're going to draw it on top of the square, and then we're going to push it to the right. And then we're going to push the same drawing on top to the bottom. And then we have our pattern completed by pushing original drawing to the right and to the bottom. Step 2. We're going to connect the transformed shapes to fill the floor without overlap, leaving no gaps. And this is our transformation tessellation.